The question, what is life, has to be the oldest scientific puzzle there is.
Oh, absolutely.
But today, with everything happening in synthetic biology, with AI becoming so powerful and our very real search for a life beyond Earth, that old question is suddenly the most urgent one we have.
It is.
And the definitions we've been using for a century or more, they're really struggling to keep up.
That's exactly where we are. The challenge today is that the question means something different depending on who you ask.
Right.
A molecular biologist is going to focus on, say, metabolism, reproduction, the actual cellular machinery. But then you talk to a physicist, and their whole focus shifts to thermodynamics and entropy.
And then you throw in a computer scientist, and suddenly it's all about information processing and self-organization. It's not just semantics, is it? These are genuinely different ways of seeing the world.
They're fundamentally opposing frameworks. And this has led us to, well, one of two places. Either what we call definitional pluralism.
Just accepting that there's more than one right answer, depending on the context.
Exactly. Or, for the more radical thinkers, it's led to this outright skepticism that life can be defined with a single universal concept at all. We're sort of in a crisis of categorization.
So our mission for this deep dive is to try and cut through some of that philosophical fog. We're looking at a fascinating piece of research that used a very modern AI-guided method to analyze 68 different definitions of life from experts across all those fields.
And they didn't just list them. They actually mapped the conceptual relationships between them into this unified, quantifiable space.
So our goal here is to give you a genuine multidimensional framework for understanding aliveness, to move past that simple binary of is it alive or not.
And to show you a more nuanced map of possibility.
And the method they used is really the story. They took 3 state-of-the-art large language models, LLMs, and used them not just to summarize, but to quantitatively assess the conceptual agreement, the correlation between every single pair of the 68 definitions.
Which transforms this centuries-old philosophical debate into structured data that you can actually visualize. It's a massive shift in how we can even approach these huge contested ideas.
Okay, so before we dive into the AI analysis, the cold, hard data, we really need to anchor ourselves in the history here. Because the tensions that the AI map reveals today, they're ancient.
They really are. For millennia, life was explained through these almost supernatural or metaphysical ideas.
Like animating principles.
Exactly. You have prana in the Vedic tradition, ki in Chinese philosophy, pneuma for the early Greeks. They were all attempts to put a name to that invisible force that separates the living world from the inert world.
And it was really the Greek philosophers who started to turn those symbolic ideas into the first real systematic frameworks.
Right. Plato saw the cosmos itself as a kind of living, intelligent being.
Then the microcosm mirroring the macrocosm.
Yep. But then you get Aristotle. And his teleological approach just completely set the mold for Western thought for, almost 2,000 years. He defined life not by what it was made of, but by what it did, its function, its properties, and crucially, its intrinsic purpose, its telos.
So purpose was baked right into the definition from the start.
It was everything. He proposed this nested hierarchy of souls, the vegetative, the sensitive soul, movement and senses, and then the rational soul for thought. And for him, the most natural act of any living thing was, and I'm quoting here, the production of another like itself.
Making life fundamentally a self-actualizing system.
A system striving toward its own built-in goal. Life was defined by its process and its aim.
And that view, that teleological view that systems have their own purpose, it completely dominated until the European Enlightenment just slammed the door on it.
It really did. That's when we get the age of mechanism. You have René Descartes, who reoriented the whole thing by seeing the body as a machine.
The famous clock analogy.
Right, the body is a machine, like a clock, governed by an immaterial mind. That was his dualism. The body's functions, he said, followed completely naturally, solely from the disposition of the organs.
But the truly radical shift came from his contemporary, Thomas Hobbes.
Hobbes just threw dualism out completely. He argued for a purely materialistic framework. Life is simply matter in motion.
He had that famous quote. What was it?
For what is the heart but a spring, and the nerves but so many strings, and the joints but so many wheels? It's a powerful, purely mechanical analogy. And that right there, that cemented the historical tension.
The clash.
The clash between Aristotle's process-driven, purposeful view of life and Hobbes' purely mechanistic, substance-driven explanation.
It's just amazing that even now, after everything we've learned about cell biology and genomics, the debate is still structured by a fight between Aristotle and Hobbes. That split really sets the stage perfectly for where we are now. So as we jump forward into the modern era, you get these huge advances in the 19th century, cell theory, Darwinian evolution, and the whole definitional landscape just splinters even more.
You'd think science would unify the definition, but it just added more layers, more powerful frameworks on top of those old tensions.
Right.
New ideas started coming from physics. You had Erwin Schrödinger, whose book, What is Life?, was just profoundly influential. He framed organisms as these systems that maintain their internal order, their low entropy, by generating and exporting massive amounts of disorder, of entropy, into their environment.
Pushing out waste heat, basically.
In a sense, yes. And then, mid-20th century, the molecular revolution hits, the discovery of DNA. And that gives birth to all these information theoretic definitions.
And that's where the computer science influence really kicks in.
It is. John von Neumann characterized life as a computational system, a system that could self-replicate with inheritable variation. It was a very powerful, very reductionist view. Meanwhile, for more pragmatic reasons, like looking for life on other planets, you get operational definitions.
Like NASA's famous one.
A self-sustaining chemical system capable of Darwinian evolution.
Which is a great definition if you're looking for pond scum on Mars. But like you said, all these definitions started running into some serious pressure points over the last couple of decades.
And that's where it gets really interesting. Synthetic biology pushes the boundaries. I mean, Craig Venter's team creating a synthetic mycoplasma cell that challenges the whole idea of natural origin. But even more challenging are things like evolutionary algorithms or sophisticated AI.
Things that adapt and learn.
And reproduce information. But without any cells, without any carbon chemistry, these things force us to question the very bedrock assumptions of all our old definitions.
So faced with this philosophical mess, how did the researchers actually use AI to find a structure in it?
Okay, so they took 68 unique short definitions from experts across biology, physics, computer science, you name it. Then they brought in 3 of the big cutting-edge LLMs, Claude 3.7 Sonnet, GPT-4o, and Llama 3.3.
And they didn't just have them look for keyword overlap or something simple like that.
No, and that's the absolute key here. This wasn't text summarization. It was quantitative semantic comparison. Each model was independently tasked with doing a pairwise correlation analysis.
Okay, what does that mean?
It scored the conceptual agreement between definition A and definition B on a scale from -1 so, opposing ideas, to +1, perfectly aligned ideas. They were judging the core philosophical meaning, even if the words used were totally different.
But hold on, isn't there a risk there? I mean, these LLMs are trained on the internet. Aren't they just reflecting their own biases from that training data rather than mapping some objective truth?
That is the critical question, and they addressed it. What they found was extremely high consistency between the models. The correlation coefficients for the results from these 3 very different LLMs were all above 0.7.
Which is very high.
It's very robust. It confirms that the relationships they mapped were real features of the expert definitions, not just quirks of one particular model. So they averaged the results into one giant correlation matrix.
And once they had that quantitative map of relatedness, that matrix, that's when they brought in the clustering algorithm.
Correct. Agglomerative clustering. Just takes all those agreement scores and groups the definitions together, revealing these 8 distinct conceptual clusters. But the crucial part is, the researchers weren't imposing categories. The categories emerged organically from the experts' own words.
All right, let's get into what the AI actually found. I know when the researchers first tried to categorize these definitions by hand, the most common themes were things like dynamics, thermodynamics, and information.
Right, each of those came up in about a quarter of the definitions, but that was just counting keywords. The deeper structure, the latent agreement, came from those 8 AI-generated clusters.
But before we get to the clusters themselves, you said there were some general properties of the definitions that were really telling.
Yeah, this gives you a snapshot of how scientists are thinking right now. First, a huge majority, almost 88%, were actionable, meaning they give you concrete criteria you could actually test.
Okay.
More interesting, though, is that 54% of them framed life as a continuous property, not a binary on or off state.
So a gradient of aliveness?
Exactly. That's a real philosophical shift away from a simple on-off switch. Also, a slight majority were objective, but observer relative was surprisingly close behind at 43%.
That move towards a gradient feels necessary, I guess, in the age of AI and synthetic biology. So let's talk about the center of gravity. Where did most of these experts converge?
That's what they called the central attractor. A full 66%, that's 2/3 of all definitions, were concentrated in this one high-density zone where 2 massive clusters overlapped. The first one was called cognitive autonomy.
And what does that mean, cognitive autonomy, in the context of life?
This cluster defines life as an information processing system that sets its own goals and maintains its own boundaries. It's about self-direction, agency, decision-making, not just chemistry. One researcher, Gordana Dodik-Prunkovic, her definition was just life equals cognition.
Wow. So agency and information are at the very heart of how most experts are thinking now. What was the other big cluster in that central zone?
That one was dispositive self-organizing systems. This brings us back to Schrödinger, but with a modern twist. This cluster sees life as a dynamic, far from equilibrium process that's defined by self-organization and the controlled dissipation of energy.
Give us a simple analogy for that one.
Think of an organism less like a rock and more like a controlled flame. It needs constant fuel in and waste out just to maintain its complex, temporary structure. Theodor Pavlov called living things statistical novelty producers. They constantly create unique new structures while still following the laws of physics.
So this central zone, this consensus, it integrates physics, information, and agency. If that's the middle, what was way out on the fringes?
The conceptual boundaries were these very small, very distinct clusters. On one pole, the reductionist side, you had informational self-replication. Only 3 definitions.
It's basically just
Information that can replicate itself. The words of Chris Adami.
only 3 definitions. Does that mean the classic life as DNA view is kind of a marginalized idea now in cross-disciplinary science?
That's exactly what the data suggests.
Right.
Replication is obviously critical for evolution, but the idea that it alone defines life is now a tiny minority view. It just doesn't account for too many other things.
And the other extreme, what was on the opposite edge of the map?
That was the perceptual categorization cluster.
Mm-hmm.
Only 2 definitions, and it was the most divergent semantically. This cluster argues that the line between living and non-living isn't objective at all.
What?
It says life is a perceptual category arising from how systems that consider themselves alive recognize and categorize others. It completely flips the problem. Donald Hoffman suggested the boundary is an artifact of the limitations of our senses.
So life is defined by the observer, not the observed.
It's exactly.
So we have these 8 clusters, but the real magic here is the 2-dimensional map the AI created, the T-SNE projection, because that's what reveals the hidden structure, the systematic ways that experts are disagreeing.
Right. The TSNE map is a visualization technique. It takes those thousands of comparison scores and squashes them down into a simple 2D image, and it does it in a way that definitions the AI thought were conceptually stay close together on the map.
And it organized everything along 2 fundamental axes.
2 axes that basically resurrect those ancient philosophical tensions we talked about at the start.
Okay, so let's break it down. Dimension 1, the horizontal axis. What's that showing us?
That axis maps the gradient from observer-relative perceptual frameworks on the far left.
Like that perceptual categorization cluster.
Exactly. All the way over to the objective, material, structural definitions on the far right, like informational self-replication. This is the modern scientific version of the old vitalist versus mechanist debate. It asks, is life intrinsic to matter, or is it defined by an observer?
And dimension 2, the vertical axis.
That one maps the tension between process versus entity. This is the old substance versus process debate, which really goes all the way back to Aristotle.
So which perspectives are at the top and bottom?
Definitions near the bottom are process-oriented. They're teleological. They focus on organization, flow, agency. That's where the cognitive autonomy cluster mostly lives.
Okay.
And then the top region is dominated by entity-based structural frameworks. Things focusing on components, physical substances, tangible mechanisms, like František Blücher's definition, living cells and all their constructs.
It's just incredible that after all this time, the core debate is still the Cartesian machine versus the Aristotelian self-actualizing process. The AI just found a way to quantify and visualize those old dividing lines.
And you can even see conceptual bridges. The definitions that the LLMs had the most trouble agreeing on, the ones that were unstable, they often sat right in those transitional zones between the big clusters. They really do occupy the borderlands between these ideas. The significance here is so much bigger than just finding a definition of life. It's the methodology. This computational semantic analysis, it revealed this robust, latent structure inside all this diverse expert thought.
Right. So instead of scientists just arguing about which definition is best, we now have a quantified map of how their ideas are related.
It allows for a kind of definitional pluralism that's actually grounded in data.
This whole deep dive really shows that the debate isn't about finding one single perfect definition anymore. It's about understanding the multidimensional space of possibilities that life seems to occupy. And this framework, you could apply it to other huge contested concepts.
Oh, absolutely. Things like cognition or memory. The ability to map these semantic territories opens up a whole new way of tackling age-old philosophical problems with quantitative tools.
Which is becoming more and more necessary as our technology keeps blurring the lines between the animate and the inanimate.
Hmm.
And that computational map, it lets us place things that are currently ambiguous. The AI didn't just map life. In a way, it mapped itself. The paper shows where today's LLMs would land on this map of aliveness
And they sit right between the cognitive autonomy and the informational self-replication clusters.
because they process information and can replicate it,
But they lack the physical self-maintenance. They're not dissipative systems. Not yet, anyway.
which leaves you with a final, provocative thought. Since this map lets us plot these ambiguous entities, what trajectory will future artificial life forms take across this landscape? And what will it mean for our definition of life when an embodied robotic system starts to migrate toward the dissipative self-organizing systems region, when it develops the ability to physically maintain itself, to control its own energy, and to actively fight against decay? That's what you should be thinking about the next time you boot up an AI.